All right, so here's the setup here. This is a torch disassembled. This is an air-cooled torch. This is the end for a Lincoln. Okay, that's where your argon or shielding gas, this chucks up to the body of the welder. Okay, and then this is just a fitting that adapts. These torches are universal. Okay, so this torch could be used on a Miller just as easily. What you do is replace this plastic chunk thing with the Miller end. Okay, so this is a Lincoln end. And this is an air-cooled torch, so in the middle of this is a conductor cable that's conducting power up to the torch through the tungsten. And then there's gas, argon, that's flowing through flowing through the hose, which is cooling the hose. This is what you call an air-cooled torch. Yours looks like a water-cooled torch, which, coming out of here, you're going to have hookups for water. So water's going to flow in. There's 3 hoses. Water flows in one hose, goes up, circulates around, and then goes back out and then dumps somewhere. If you have a cooler, then it obviously does it through the cooler. But if you just have it hooked up to a faucet, it's just going to run continuously water through. And for what you're doing, it doesn't really matter. And then you're obviously going to have a hookup for gas. Okay, but the reason you can't run a water cooled torch is that the conductor cable, it doesn't have anything else around it, okay, other than a little jacket of water, and it doesn't have any argon cooling it. So if you run the water cooled torch without water in it, it's going to heat up and it's going to melt through the cable pretty quickly. But you could use it for 2 seconds just to test it. It's not going to, but you don't want to run it for a couple minutes or something like that. All right, so here's how it all goes together. So torch body. Okay, you're going to put the collet body in first. Okay, now this is a gas lens setup, okay, which has a little mesh screen in it. It's got some shit on it, but whatever. Gas comes through here. There's other collet bodies that might look a little different than this, where they have holes drilled around the outside where gas comes out. The cup goes on here, goes through the cup, but basically there's no difference really, other than this is just to give you a better laminar flow, but it doesn't really matter. All right, so, and again, everything is just hand tight here. Collet body screws in there. Collet goes in the back side of the torch. Your cup screws on here. This is a red tungsten. It's got a little red band on it, which means it's thoriated. This is 2% thoriated tungsten. This is used for steel, stainless steel, whatever. You can see there's a pencil point sharpen on it. This tungsten's dirty. I've dipped it, or it's just gotten fuzzy. So you would grind this on a grinder to a pencil point, and you would always grind axially. So you would never grind like this and spin it, because you'll get an uneven arc. So you're going to hook up a grinding wheel and just spin this thing in your fingers and grind that to a pencil point. But for what you're doing, if there's a tungsten there, just use it. It's not going to matter. Tungsten goes in the back like that. Okay, and that's your stick out. The rule is 2 to 3 times the diameter of the tungsten is how far you want it sticking out. And then what this back cap does is it seats the collet, which grips the tungsten, and it also has an O-ring here, which seals the torch up so that the argon or whatever, the shielding gas is coming up through here, is only going out the front. If you have a leak in there, you won't be shielding it and you'll get a crap weld. So now I've locked this in, which is lock the tungsten in place. And that's it. So to weld steel, say you get 1/8 inch steel, run it about 90 amps on the panel, okay? And you're going to set your tungsten, basically the width of this tungsten away from your base metal. So you're going to set your arc length, the distance between your metal, at about, let's just call it 1/8 of an inch. Okay, it's really a 1/16 inch tungsten, but it doesn't matter. So 1/8 of an inch, and floor it. Turn your turn the machine on, turn the gas bottle on, so open the gas, set the gas flow to 15 cubic feet an hour. On the panel of the machine, you'll have a post-flow setting. Set that to 15 seconds, which is how long it's going to continue to flow shielding gas after you release the pedal. And that does 2 things. It cools and shields your puddle under argon or CO2 argon mix so that you don't get contamination in your weld. And it also cools the tungsten down. Okay, so the post-flow is important, sort of. but not for what you were doing. I mean, it doesn't even matter. So anyways, get that, hold it just about like this. You don't need filler rod. You're not going to be welding. You're just checking to see the machine works. You don't need filler rod in your hand. So just don't touch it to the metal. Okay, just hold it up 1/8 of an inch above it and floor it. Floor on the pedal. And within 2 seconds, you should see a puddle appearing. You've looked at enough MIG welds to know when a puddle happens. So you'll see a puddle happen within 2 seconds. Back off on the pedal. And that's it. Machine works. To do AC, alternating current, so, and I forgot to tell you, to do steel, you set the machine to DC negative. To do AC, turn the machine to AC. Okay. Ideally, you'd have a green tungsten in here because that's what you use for aluminum, but in your case, it's not going to matter. Take your 1/8 inch piece of aluminum, bump the amps up, to 100 or whatever, doesn't matter, and do the same thing. Now, I'll warn you, with aluminum, with AC, it's a lot louder. You're going to get a zzz, like, it sounds like you're getting electrocuted, but you're not. It's the alternating current of the machine. So the machine's rapidly switching back and forth, and it's a lot louder. So just be prepared for that if you've never welded aluminum. Same everything. Set the machine up, argon, just bump the amps up a little bit, switch it to AC. Like I said, in a real world, you'd use green tungsten, but you'll get a melted piece of metal with thoriated, so don't worry about it. Same thing, hold it there, floor it, 2 seconds, you should see a puddle. Congratulations, AC works too. And that's it. But I'll walk you through it if you want me to, but that's about as simple as it gets. It's not as intimidating as it looks. Just, make sure you got a bottle, you have a tungsten that works, you have some metal, you have a place to plug it in. If you're really worried about that water-cooled torch setup, then I would probably figure out a way to jimmy rig some water or something flowing through it, hook up a hose or something. But if you're just going to do it for 2 seconds, I wouldn't worry about it. A new torch is a couple $100, so don't go frying that unintentionally.